Okay, now we're going to start looking at specifically quadratic functions. This example 4 is actually a review from the past, so why don't you go ahead and take a moment and see if you can describe what transformations happen from x squared to get to the graph of this function with all these transformations applied. Pay attention to order. Okay, pause the video and give that a try. All right, so hopefully you paused the video and you filled this out. Okay, there's two different transformations. There's a single horizontal translation because there's one thing applied to the x, and then there's two vertical. So let's take care of that single horizontal one. Okay, this says it goes x minus 2, which moves me right 2. That's in with the x. That gives me my horizontal translation. Now this might be your third option. You could write this either first or last. Okay, the other two specifically have to be in this order. We've got this 2 times the whole squared quantity and the plus 3. Remember, stretching and shrinking has to happen first. This is in a vertical translation, so it's going to happen exactly like we see it. So 2 times x squared will actually stretch it by a factor of 2. I need to mention that that is vertically. And then we have this plus 3 that moves my graph up 3. Okay, that's what we get for our translations there. Okay, then we have the general form and vertex form of our quadratics. Let's start with vertex form because that's the one that lines up most with what we just did. Vertex form looks like this. F of x equals a times the quantity x minus h squared plus k. If this is our general vertex form, if we compare this to a plain old y equals x squared, we understand that this would move right h units and it would move up k. Okay, there's those two pieces to that. In a normal parabola, when it's just plain old x squared, our vertex starts at 0, 0. And so if I move it right and up, or however I move at h units and k units, my vertex moves with that, and my vertex becomes h, k. The minus h moves me h units right and left. The plus k moves me k units up and down. Okay? A parabola also has this idea of symmetry. It is an even function. It has symmetry over a y-axis to start with. But once it starts moving, it no longer is over the y-axis, but it still has a reflection over a vertical line. And that axis of symmetry goes through the vertex. So it has this vertical line at x equals h. Then we have, that's our vertex form, where I can directly see that key piece of information about where this bottom of the parabola is located. It's a nice form for graphing. But it's not always the form we're given our quadratics in. There's our standard form, which is simply ax squared plus bx plus c. Okay, we could, and we'll look at how to do that, transform our function from this form to this form to be able to identify our vertex. It's not a bad way to do it. There is a shortcut, but I don't like memorizing very much, so I'm not asking you to have this memorized. I'm just going to show it to you, and if you want to use it and memorize it, you're more than welcome to. In general, the vertex will be found at the opposite of whatever b value this is, divided by 2 times the a. That would give you the x value of your vertex. And then to find the y value, you have to plug in that x value to get the value of y. So whatever x you get, put it back into the function and get your value of y, the function. And that tells you your y. And just like we saw before, the axis of symmetry goes through the vertex. So it's a vertical line, so it's x equals whatever that x value is, so negative b over 2a. Okay, that's kind of our basic information for graphing that we need to be familiar with. Okay, let's go on to the other side. So let's continue on with our quadratic function notes. So here it says use the vertex form of a quadratic function to find the vertex and axis of the graph. And it gives us our function in our standard or general form. So the first thing it asks us to do is rewrite it in vertex form. Okay, if you remember back to, I believe it was chapter P, where we were doing that idea of completing the square to solve our quadratics. Here's the reason we actually require you to learn completing the square, because that is something you have to be able to do at this point in time. We need to be able to convert this function to our general vertex form, which has that x minus h squared, a perfect squared binomial, or binomial squared. So we need to create a perfect squared trinomial. We need to do completing the square. So here we're going to look at how does completing the square look when I'm converting from standard form to vertex form. So we start with our original function, which is f of x equals. Now remember when we did completing the square, it only worked if I had just a plain x squared. And this is 2x squared, so I'm going to need to, and unfortunately this time I have to factor it out. I can't simply divide it away because I can't divide the left side. That won't give me a plain old y equals. So I factor out the 2 from the two x terms. X squared minus 4x. I need room there to be able to write my third term. And so I leave a little space, and then I put my plus 11 just a little further to the right so I have space. Okay, now let's see what we remember. What needs to go here in order to have a perfect square trinomial? And hopefully what you're thinking is half of b. Let's put our little quick reminder here. Remember, it's x squared plus bx. To find that c value, we take our b, we divide it by 2, and we square it, and that tells us c. And then once I have that, the binomial that's squared is x plus this b over 2. Okay, that's a quick refresher of what we did before. We took half of b, squared it, that gave us our third term. When we wrote it as a binomial squared, we specifically looked at this b over 2 as our second term for the binomial. Okay, so here's, we're looking at this one. We take our negative 4 divided by 2. It's negative 2. Negative 2 squared is 4. So I need a plus 4 here. But I can't randomly add something to a side of an equation and consider it still the same. Okay, and I don't want to change anything on the left because I want this to be a function. I want it to be just f of x equals. So what we're going to do is actually undo what we just did on that same side. So here, pay attention to the fact that there's this 2 on the outside that multiplies that 4. So I really, when I put that plus 4 there, added 8. And so I need to undo an adding of 8 by subtracting 8. Okay, and then I've added 0 to that side. I've added a plus 8 and a minus 8. I've added 0. So I haven't really changed anything. It's still the same function with the same values. Now if I write that nicely in its vertex form, we have 2 times taking this trinomial, writing it as a binomial squared, I get x, and then plus the b over 2, which was negative 4 over 2, just negative 2. So x minus 2. And then simplifying here, 11 minus 8 is 3. We have our vertex form of our parabola from our standard form. Okay, then we need to usually be asked, and it actually says find the vertex in the axis of symmetry. So we've got vertex. Okay, the minus 2 shifts my graph right 2, so my x value of my vertex is 2. The plus 3 shifts it up 3. Okay, and then we have our axis of symmetry. Which is the vertical line that goes to that vertex. So it's the equation of the line is x equals, because it's vertical, and x equals 2 because the x value of the vertex is 2. Okay, and from there we could draw the rest of our graph by either making a table or using our calculator to plot some points. We need to be able to identify those key points on our graph. Okay, here we're going to do it one more time. Let's take a look at our original function. We're going to do completing the square. If you feel comfortable at this point, go ahead and pause the video and try it yourself. If you want to walk through it with me, just stay here and we'll walk through it. Okay, so here's h of x. And I know I can't work with a negative 2x squared. It has to be a plain x squared, so I'm going to factor out the negative 2. And so here I have negative 7, and I'm factoring out a negative 2. I'm dividing it by negative 2. So negative 7 divided by negative 2 becomes a positive 7 over 2. And I don't have my third value, so I'm going to leave that, because we'll get that in a moment. I need to move that minus 4 over. Okay, I'm literally just moving it out of the way. I'm not changing anything because it's still on that right side of the equation. Okay, now I need to decide what goes here. And then I need to undo it here. And so if I take negative 7 halves, divide it by 2, or better yet, multiply it by a half, I get 7/4. And then I square 7/4 to get 49/16. But 49/16 is not really what I added to this side because this is in the parentheses that are multiplied by negative 2. So really, I added multiplying by negative 2 and reducing gives me negative 49/8. So here's a negative 49/8, so I need to add 49/8 to the right there, so that I've put a negative 49/8 and a positive 49/8 in order to have 0 added to that side. Okay, then writing it in my general vertex form means take that trinomial and write it as its binomial squared. Okay, and maybe I'll go ahead and simplify this. If I have negative 4 and I add 49/8 to it, that's negative 32/8. Adding those together gives me 17/8. Okay, and here it's x, and then half of b, which was at 7/4, so plus 7/4. Okay, let's actually talk transformations, because I know that was something a bit challenging from last chapter. So if we look at this and we say, how does this compare to our basic form f of x equals x squared, the parent function x squared? Okay, pay attention to all of our transformations. There's only one horizontal transformation in with the x. All I have is a plus 7/4. So that means I move left 7/4. Okay. Then I have the two vertical changes. Actually, I have 3 of them because there's a negative and a 2 and a plus 17/8. So these next 2 can happen in either order. We have the stretching and the reflection. Okay, those 2, the order doesn't matter. They just have to come before the shifting. So I've got this fact that it's stretched by 2 vertically. Sorry, that's off the graph or off your screen. And then it's a vertical reflection. So vertical reflection has to be over the x-axis to change vertically. So we reflect, oh boy, that's terrible spelling today. Reflect, there we go, over the x-axis. And then this plus 17/8 shifts me up 17/8. Okay, that's how this graph has changed from the original function, or its parent function, of x squared. Okay, you'll be asked a few questions like that, so I want to make sure that we have that. Okay, that's the idea of describing the graph. Okay, it says use complete and square to describe the graph. Here is our description of the graph. This is what we'd actually be looking for in this.